What's inertia? When in space traveling at high velocity, your ship experiences inertia. That's optical vacuum space dragging. Because you're traveling with the fabric of space, your ship fighting against the space vacuum void, which relativity theory pertains, is a fabric material of space or a volume. That pressure only allows you to travel half your speed. In his equivalence principle, your ship gains mass. It's like a car of the road. Let go if the gas pedal and your car slowly comes to a stop. In space, Einstein asserts the same reasoning, but in SOS, your ship needs to reverse forward thrusters to slow down from its velocity. It doesn't slowly come to a stop like your gas-driven car. So reverse thrusters are needed, or you just keep traveling and traveling through the dark void. Do you think Einstein is right about inertia, or do you think us wrong? Your choice. These facts are supported by the Quanta Physics Theory Interpretation by Rodney Kowecki, January 2026. If you are in space and your ship is traveling at light speed, you are essentially traveling not in time, but 1 second per second. According to relativity theory, a ship traveling close to light speed in space, the passengers live forever. In Albert Einstein's equivalence principle, all is relative. In the ship reaching light speed, time slows down and stops. Accordingly, the passengers live forever. Those the facts in special relativity. There are several ongoing disputes and debates surrounding the theory of relativity. Some of the major points of contention include: 1. Einstein's theory of general relativity versus quantum mechanics. The theory of general relativity, which describes gravity and the curvature of space-time, is at odds with the theory of quantum mechanics, which explains the behavior of particles at the smallest scales. Scientists are still trying to reconcile these two theories into a single unified framework called quantum gravity. 2. The expanding universe versus steady state theory. The observation that distant galaxies are moving away from us, suggesting that the universe is expanding, is a cornerstone of the Big Bang theory. However, there have been proponents of the steady state theory, which proposes that the universe has always existed and is continually creating matter to maintain a constant density. The evidence strongly supports the expanding universe, but the debate continues among some physicists. 3. The existence of black holes. While the existence of black holes is widely accepted, some physicists still question their properties and the nature of the event horizon, the boundary beyond which nothing can escape the gravitational pull of a black hole. Alternative theories and explanations have been proposed, challenging the conventional understanding of black holes. 4. Time travel and wormholes. Einstein's theory of relativity allows for the possibility of time travel and wormholes, shortcuts through space-time. However, these concepts remain highly theoretical and debatable. Some physicists argue that the existence of wormholes and the possibility of time travel violate various laws of physics, while others explore the implications and potential mechanisms of these phenomena. It is important to note that scientific debates and disputes are a normal part of the scientific process as scientists continue to refine and expand their understanding of the universe. Finally, for AAN, increasing of mass of a moving object or shop traveling through space to HAOKN, mass due to the increase of acceleration. The environment of that space must have a core gravitation energy attraction force. For example, Earth gravity force measures 50% acceleration, attaches a 50% of attraction from the Earth's core. The core of the universe is unknown. It is speculated in Hubble expansion. More so, as the universe expands, it's viewed as a uniform of motion that a push force is constantly pushing the galaxies away from each other. In a tactic or subtle universe, as you have read, clearly there is no change as expanse gives us, and festivities, gravity well makes no universal momentum amongst the stars. So actual gravitation like Earth gravity force is what allows mobility of non-attached object movement, a measurable force on different planets with different measures of gravity. Space is a vacuum with not an attraction force, but just the opposite, as a push force instead. Under such definition of an empty vacuum, there exists no positive attraction energy. The positive force of the space vacuum is a positive push force. This push force is calculated at a much greater energy amount than light speed energy. It is also constant. The slow drag of the vacuum push force is measured by the Hubble equations. And as an energy force, this vacuum energy has to measure much greater than Hubble's 42 mics per second to excel the galaxies apart in uniform motion, an activity that is not only constant, but equal to each end if a resplusiveness. Can it be described as a space energy called the dark energy, or is it a physical anomaly as the Hubble universe expanding the dark element?